Let's look at spheres. Now we require the radius of the sphere. So let's say r is equal to 2. Now the simplest case of a sphere is when it is centered on the origin. So in that case the equation becomes x square plus y square plus z square is equal to r square, right? So that is the equation of the sphere centered at origin. Now let us say we don't want it on the origin, we want it somewhere else. In that case, what we require is, let's make it as a point. Let's say we want it centered at A. Okay, so in that case the equation would become x minus a1 square plus y minus b1 square plus z minus, let's put the bracket, z minus c1 square is equal to r square. Yes. So here a1 b1 c1, that is A, is the center, right? Okay, so this is what a sphere is. Primarily two characteristics. One is the center of the sphere and the radius. And the points, all the points which are equidistant from A forms a sphere. Okay, now let's delete off all this and let's start from scratch again. Okay, now another way in which we can represent a sphere is by using what is called as the standard form, and that is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, right? And we can, we can move it around. Okay, so let's not make it too big. Okay, now what we want is the radius of this sphere. So radius would be what? R is equal to square root of u square plus v square plus w square minus d. This will give you the radius. Now let's see what GeoGebra says. As per GeoGebra, what the radius is. So radius of EQ1, as per GeoGebra also it is 4.43. Okay, now let's figure out the center of this. So center of this would be minus u comma minus v comma minus w. See here, that is the center of the sphere, that is A. Now what we want is a point on the sphere, somewhere on the sphere. So the easiest way of doing it is, let's say x1 is equal to minus u, y1 is equal to minus u, and z1 is equal to minus w plus the radius. And let's define this as a point x1 comma y1 comma z1. Okay, it's not coming on the surface of the sphere, somewhere I mean, okay, this should be v, right? So it is on the surface of the sphere. Okay, now what we want to figure out is there's not going to be one tangent at this point, isn't it? there are going to be lots and lots of tangents in all the directions, right? So uh, instead of calling it as a tangent line, let's add up all the lines to form a plane. So we call it as a tangent plane. And the equation of that is x1 times x plus y1 times y plus z1 times z plus u times x plus x1 plus v times y plus y1 plus w times z plus z1, and finally plus d equal to 0. Now if we rotate it, you will notice that this plane touches the sphere at only one point, and that is B. So using this equation, what we can do is we can figure out the equation of the plane which touches at a given point on the sphere. Okay, so that is, and this particular point is called the point of contact. Yes, or plane of contact. This is a plane which has a contact at this particular point. So plane of contact. So we saw sphere, we saw um, centered at origin, centered elsewhere. We saw the standard form of the equation of a sphere, and we saw the tangent plane and the plane of contact. Now a few additional things. Uh, if we connect these 2 points A and B, right, A comma B, then in that case this is nothing but the radius of the sphere. This radius would be perpendicular to the plane, or in other words the plane would be perpendicular to the radius. Okay, so that is one thing. Apart from that, if you are given a plane and a sphere in the equation forms, the only thing you have to figure out is the distance of this plane from the center of the sphere. If it is equal to the radius, that means this is a tangent plane. Okay, so those are two additional things I wanted to mention. That's it. Bye.